So we're looking at the third topic now, threats to an organisation. Now this is going to have some crossovers with threats to individuals and things like that and vice versa, but let's just have a look at these ones that are just mainly threats to an organisation. Now first off is denial of service. Now a denial of service attack is designed to stop a website from working. Softwares or computers, things like that, they will send lots and lots of requests to a website which will stop it from being able to run its services. So it might be logon requests or requests for data, and it will do tens of thousands every second, and the server will just seize up and stop working. And this is normally at high profile targets, so I've got banks as an example here, but it could also include things like shopping websites, government information sites, things like that. So that's what denial of service is. Lots of requests which stops you as a user being able to access the website and the website from running. Obviously, if this is a shop, you'll find that people can't get onto your site to buy things. Obviously, you'll lose money, your reputation, all sorts of things like that are things to think about. A distributed denial of service attack, which is more often the one that you do see for big organisations, is an attack that comes from more than one location. So basic denial of service comes from one location, one IP address, and actually it's easy to block that. But a distributed one, it comes from lots of places all over the world, so you can't actually block every single location coming in. So it's a lot more successful, a lot harder to deal with. The next one is something called SQL Injection. Now this is one that is for any website that's got a login or a database behind it. So all websites have to store their user data in some kind of database. So Facebook, Amazon, eBay, Microsoft, all of these sites have databases. And some of them use a language called SQL, Structured Query Language. This is a database programming language that people use to query the database. So it will say you put your email in or your username, and it will find you. It's querying it, it's searching it. And then instead of just finding your name, criminals can put in special commands, or hackers can put in special commands that will either display every username, or it could delete our database. So we've got a couple of examples here. The picture's one. So on that one, it's got an email address, but it could be a name. And then you type in the word or, 1 = 1. So what this does is it searches the database for the username or email, but even if it's not there, if 1 = 1, then it's going to show all the information or allow you to log in, because 1 will always equal 1. So it's a little trick to get round finding the correct user. The first example that I've got there is I've written Bob as a name, followed by drop table students. Now drop table is a special command in SQL, which means delete the table. So that code would actually delete a whole part of the database. So this is obviously something you don't want if you've got your own website. So you use something called input sanitization. You'll hard code into the program filters, and these filters will get rid of any potentially harmful inputs from users. So if they were to type or 1 = 1 or drop table, it would say, no, we can't do that, that's a failure. So that's how you can solve SQL injection attacks. Now a couple more here. We've got zero-day attacks. Now 0 day seems a bit weird, seems like a zombie movie, but whenever you create new software, it's tested really, really thoroughly, but sometimes there are flaws. Sometimes there are mistakes that developers make. And the 0 day is the day that it's made public or it's discovered that there is a flaw in the software. That is 0 day. And then it starts a race. So you've got your hacker desperately trying to find a way to exploit the flaw, trying to work out how you can hack into the website or the software. A developer is trying to fix it, trying to find a way that hackers can't get past it. So the 0 day is the day that a flaw is discovered, and that is a 0 day attack. Finally, we have ransomware. Now, ransomware obviously does happen on individuals. Your data can be attacked there, but it's a lot more painful for organizations. So organizations might have databases. They might have huge amounts of important information. And if they get a ransomware attack, it could block access to the data or threaten to publish it, which is really bad if you're working for a financial organization or you're working in sales or other businesses. And they will they'll either block or publish it unless you pay a ransom, unless you pay some money. Now, it can encrypt the files, making them inaccessible. So we talked about encryption when we talked about data interception to make them unreadable. Well, this type of malware, ransomware, does that to your files, your own files, and then doesn't actually allow you to decrypt them unless you pay the money. Now, ransomware can be built into either Trojans or worms. It's just a way that it distributes it across the systems. But it's really bad. And it's something that's been coming in over the last 5, 6, 7, 8, 9, 10 years. Ransomware is becoming bigger and bigger. There's a lot of money. People are paying money in bitcoins and things like that. So it's a lot harder to track where this attack is coming from. So in summary, we've got a distributed denial of service or denial of service attack. So it's flooding a site with network communication to make it grind to a halt. You've got SQL Injection, so special commands to hack a database and input sanitization to stop it. Zero-day attacks, so it's a race from when a flaw is first discovered to see who can hack or fix it first. And finally, ransomware, so it's malware that holds your data to ransom.